With the mathematics. Today we on the 2023 Universal Florida Integration B qualifying round, and we'll look at the first part that involves solving the first 10 problems. Problem 1, problem 2, problem 3, problem 4, 5, 6, 7, 8, 9, and 10. So this is what we'll be focusing on today. My encouragement to us is, if you're here for the very first time or second time and haven't subscribed to our channel, we do really encourage you to consider subscribing to our channel here at Everyday Mathematics. What we do is we love mathematics. We go about and around, look for interesting problems, we solve them, we share with you. So without much ado, we'll go ahead and start solving these 10 problems. Problem number 1, that's the indefinite integral of cosine of 2023x times cosine of the sine of 2023x. So how do we solve this? The first thing is, let's look at this part here, and that part there can be expressed as the derivative of 1 over 2023 of sine of 2023x, right? And then we have cosine of sine of 2023 of x. Okay, so with that in mind, what that allows us to see is that what we have under the integral sign is just the derivative of 1 over 2023, and this part here is going to be the derivative of sine of x, but because there's a nested sign in here, that is being taken care of here. So essentially, this is what we have. Okay, and we can pull the constant out, and since we're integrating a derivative, what we have is 1 over 2023 sine of 2023 x plus the integration constant. And that, ladies and gentlemen, is our answer. So sometimes it just involves looking around and seeing that what is being done here is trying to differentiate the nested part right there. And then you can solve your problem. So that was a very easy problem. I didn't really need us to do a lot, but I hope that can be of help to somebody. Then on to problem number 2. Number 2 is the definite integral from x equals to 0 to x equals to 17 of 14x times open bracket 1 plus cosine of 7x squared close bracket. So my inclination here is to expand up everything so that we have integration from x equals 0 to x equals 17 of 14 of x plus 14 of x cosine of 7x squared. As you can see here, this happens to be the derivative of 7x squared. So borrowing from what we did from problem number 1, this is the same as 0, 17, integration of 14x plus the integration of the derivative of sine of 7x squared. Right? Just borrowing from what we did in problem number 1. Okay, we have a nested component here being differentiated. So since we have here now a derivative, we can integrate this, which is going to be 7x squared, right, plus sine of 7x squared, and then we'll put a bracket here, but we do have our limits here. Okay, now 17 squared, what is 17 squared times 7? 17 squared times 7 is it's 17 times 7, 289 times 7, which is 2023. So we have 2023 plus sine of 23. Now the lower bound, we have 0 minus sine of 0, which is 0. So this happens to be our answer. Okay, so that was problem number 2. Now we're going to move on to problem number 3. Problem number 3. Problem number 3 is interesting because we have cosecant of x times cotangent of x times secant of x. Now, with this secondary trigonometrical function, I think the important thing for us is to try and express them in form of the primary functions of sine, cosine. And so what we're going to do is we're going to just say, okay, this is the same as the integral of 1 over sine of x. So that is cosecant of x. And then cotangent is the same as cosine of x over sine of x. And then secant is the same as 1 over cosine of x. And see that and that do cancel. So we do have 1 over sine squared of x. And that's the same as 1 over 1 minus cosine squared of x. Probably don't need to do that much, but if I say let t be equal to tangent of x, what happens there is that dt dx is equal to sec squared of x, and so dt over sec squared of x is equals to dx, and this is the same as 1 plus tangent squared x, so this is the same as 1 over t plus t squared is equals to dx. Now, also, maybe to try and understand what is happening here, by letting t be equal to tangent of x, if we say the best angle is x, and so tangent being opposite over adjacent, so it's the same as t over 1, and the hypotenuse becomes 1 plus t squared. Now, that means that our problem, that is integral of 1 minus cosine squared of x dx, is the same as 1 over minus 1 over 1 plus t square root of t squared. This is squared, and then dx is the same as dt over 1 plus t squared. So this is the same as 1 over 1 plus t squared minus 1 over 1 plus t squared over 1 plus t squared. And this and that cancels, so we have the integral of 1 over t squared, which is the same as negative 1 over t plus c. But we had said that t is tangent of x, but we say but t was equal to tangent of x. So in other words, our integral of cosec of x cotangent of x times sec of x is equals to negative 1 over tangent of x plus c, which is equals to negative cotangent of x plus c. And that is our answer. Okay, so we'll move forward to number 4. Problem number 4. So what happens here, we have an indefinite integral of 1 plus cotangent squared of x times cotangent of x over cosecant of x. Now 1 plus cotangent squared of x is the same as the cosecant squared of x. So what we have here is cosec squared of x times cotangent of x over cosec of x, right? And so that and the square goes away, so we essentially have 1 over cosecant of x is same as 1 over sine of x times cosine of x over, let's put bracket there, just cotangent is the same as cosine of x over sine of x. So, and then we have cosine of x over sine squared of x. So this is an interesting problem because cosine of x is the same as the derivative of sine of x. Okay, and since seeing here is that this is the same as the derivative of negative 1 over sine of x. And therefore, if we're integrating the derivative of a function, this is the same as that same function, so we have 1 over sine of x plus integration constant c. And that is our answer. Okay, so then we'll move to problem number 5. Problem number 5, that happens to be the indefinite integral of secant of x times tangent of x over sine of x times the cotangent of x. The first thing I'll do is just to express the especially cotangent of x in its in form of the primary trigonometrical functions. So we have secant of x would be 1 over cosine of x. Tangent of x, let's just keep it like that. And then sine of x, then we have cosine of x over sine of x. So those cancel, and this interacts with this, so we have sec squared x tangent of x. And we know that secant of x is the same as the derivative of tangent of x. And we can use integration by parts, where if you have a product of a function v and the derivative function u, and you integrate it, you have uv minus u, the derivative of v. So using that, I can choose this guy to be u and this to be v, so that uv is tangent squared of x, and then u being tangent of x, and the derivative of tangent of x is sec squared of x. We realize that this is the same as I, if this is our I, right? So we have 2I being equal to tangent squared of x plus c, and so I is equal to a half of tangent squared plus, we'll keep c as c. Now, the important part here is we've said that integration of secant of x times tangent of x over sine of x times cotangent of x is equals to a half tangent squared of x plus c. But also tangent of x is the same as sec squared x minus 1, right? And so plus the integration constant prime. So these two answers are the same, right? Without loss of any generality there. So let's go to problem number 6. Is the indefinite integral of the natural logarithm ln of e to the x. Now, for those of us who know that a natural logarithm of e to the x is the same as, because we're looking at base of e, that's the same as the integral of x. And so we have, and for, this is the answer for now. Anyone who may be wondering how we got there, if u is equals to this, then it means that e to the u is equals to e to the x, and therefore u is equals to x. And that's how we got there. Yeah, anyway. Let's go to problem number 7. Problem number 7 is the indefinite integral of 1 plus secant squared of x times the natural logarithm of sine of x. Now, how do we solve this? I think I can express this as 1 plus, this part here is the same as the derivative of tangent of x. Okay? Using integration by parts for this part specifically, taking tan of x as u and as u and this as v, we have the integral of that plus uv is tangent of x minus we have tangent of x times the derivative here where we have cosine of x over sine of x. And since this part here is a reciprocal of tangent of x, so this cancels and we do have 1, right? So we have integral of 1 plus tangent of x, natural logarithm of sine of x, minus the integral of 1. And this would obviously cancel. So the final answer is the tangent of x times the natural logarithm of the sine of x plus the integration constant, obviously. And that is our answer. So moving to problem number 8. Number 8 happens to be the indefinite integral of the natural logarithm of x, which can also be expressed, since there is a hidden one here, which we can express as the derivative of x times the natural logarithm of x. Now, using integration by parts, v du is equals to uv minus u dv. Our du is this part, our v is this part. So uv is going to be x, natural logarithm of x, minus x times the derivative of natural logarithm of x is the same as 1 over x. And so we have x minus the integral of 1, which is x natural logarithm of x minus x plus c, integration constant. And that is our answer. The next integral is the definite integral from x equals to -6 to x equals to +3 of the floor function or sine of pi x plus the ceiling function of cosine of pi x. So what I would want to do here is first separate this into two separate integral, because that's okay for me. Okay. And then what is a floor function? The floor function of a function fx is equal to k in the interval when is less than k plus 1, in that interval. And then the ceiling function is of fx is equals to k plus 1 in the interval k is greater than fx but less or greater than k plus 1. So that's that. Now personally I would like to plot these guys out. So I have, let's say 0, and we have 1, 2, 3. We have -1, -2, -3, -4, okay, next, -5, -6. So 1, 2, 3, -1, -2, -3, -4, -5, -6. So sine of pi is going to be and then okay, and if this is +1, this is -1, that means that in the interval 0 to 1, since it's only 1, sine pi x is only 1 at this point here, everything is 0 until this part where, and then it goes back to 0. Now at this point here it is 0 here, but all here we have it's -1 until it's there, and then here it's going to be 0 until we have 1 at this point, and then back to 0. Similarly, we have sorry, this is 0, this is -1 all the way, and then here, and then here, -1 all the way, and then here we have so and so in other words, the area we are looking at is here. So in other words, we have -1. So this is 1, 2, 3, 4. We have 4 squares, 1 by 1. So in other words, the area there is -4. So here we have -4. Then let's look at the cosine part there. So we have 0, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, -1, -2, -3, -4, -5, -6. And so for cosine pi x, it's +1 here, and then it drops I becomes -1 there, goes +1 there, something like that. Then 0, -1, +1, -1, +1, -1, like that. So since we're looking at the roof, and this is what we're going to use, between 0 and 1, or let's begin from the very end here. It's going to be 0 here. So this part is going to be -1, and so to here is 0, to here it's going to flip to 1, with the exception of the ends here when it is 0. And then it is 0 all the way at this point there. And then here we have like that, like that. And then it's going to be 0 with the exception of that. It's going to be, and here it's going to be 1 at the edges. It drops to 0. And then here it's going to be 0 with the exception of that. And here it's going to be 1 with the exception of the edges. And then here it's going to be 0 with the exception of the center there. And here it's going to be, so 1 with the exception of that. So in other words, we have, this is going to be half, but this is 1, 1, 1. So we have 1, 2, 3, 4, and then we have half here. So in other words, here we have +4 and a half. So the area -4 plus 4 and a half means that our integral from -6 to +3 of the floor of sine of pi of x plus the ceiling of the cosine of pi of x is equal to 1/2. And that is our answer. So problem number 10, which happens to be the indefinite integral of x to the power 1011 times the absolute value of x to the power 1012. So, well, the first thing for us to know is that what is x? What is x? Absolute. It means that if x is a negative, then it becomes, so absolute x is equal to 0 when x is 0. The sine of x, which is negative in the times x when x is less than 0, and just x when x is greater than 0. So in other words, our integral x to the power 1011 times absolute value of x to the power 1012 is the same as sine of x to the power 1012. So it's obvious that if it's negative, since this is an even power, this is just going to be positive. So this is essentially 1. So we have x to the power 1011 times x to the power 1012, which is the same as x to the power 2023. And this is 1 over 2024, x to the power 2024 plus the integration constant c. That's the answer. So it was a trick question, didn't really require much of the thinking, but all the same, I hope you learned a thing or two. So that actually brings us to the end of our solutions today. I'd like us to end here. Until next time, I hope you have a blessed day ahead. If you haven't subscribed to our channel, we do encourage you to subscribe to our channel. If you like what you see, please leave a like. If you have a question, please don't hesitate to leave a comment. Until next time, bye-bye.